The internet feels wireless. It isn't. Somewhere beneath the ocean, your messages are racing through glass. When you send a photo to someone overseas, it may leave your phone by Wi-Fi or mobile signal. That is the wireless bit. Then it reaches a local network, travels through terrestrial fiber, and heads for a cable landing station near a coast. From there, the journey gets wet. The cloud, it turns out, has cables. Across the ocean floor lies a web of undersea fiber-optic cables. They carry the great majority of international intercontinental data traffic messages, video calls, banking requests, game updates, cloud backups, and the very serious business of refreshing a group chat. Inside each cable are earthen glass fibers. Data becomes pulses of light, not tiny emails swimming through a pipe. Light flashes, encoded as information, racing along glass. Repeaters spaced along long routes boost the signal so it can keep going across an ocean. Why not use satellites for all of this? Satellites matter. They are vital for remote places, resilience, broadcasting, navigation, and connections where cables are impractical. For huge volumes between continents, fiber is the workhorse. Its route stays far lower than an orbital trip, and a cable can carry vast capacity. The internet is not a single machine. It is a sprawling relay race, with glass as the baton. Getting a cable across an ocean is an engineering operation, not a very long extension-led. Survey ships map the route. Cable-laying ships feed the cable overboard. Near busy shores, it may be buried beneath the seabed for protection. For offshore, it often rests on the ocean floor, where the scenery is dramatic but the foot traffic is reassuringly low. Still, cables can be damaged. Fishing gear, ship anchors, seabed movement, storm-driven changes near the coast. Sometimes a fault is small, sometimes it is a clean break. Either way, the internet does not usually throw its hands in the air and go home. Networks are built with multiple paths. When a cable fails, traffic can be rerouted through other cables and terrestrial links. That may add congestion or delay, especially where routes are limited. But one cut does not normally unplug the planet. It is less like one bridge collapsing and more like a city sending traffic through different streets. Annoying, yes. Apocalyptic, usually not. Then comes the ship. A specialized cable repair vessel heads to the suspected fault area. Engineers narrow the fault from network measurements. The ship holds position and sends grappling gear down. It is like fishing for a garden hose in the dark, except this one carries international communication. Once recovered, the damaged section is cut out. Technicians splice the fiber, protect the joint, test it, and lower the repaired cable back down. Close to shore, it may need to be reburied. The repair can take time. Weather, depth, permits, location, and the nature of the damage all matter. The hidden network is resilient, but it is not magic. And that is why this matters. Your documents, calls, streams, payments, and photos depend on data centers, cables, coasts, and repair ships. The cloud sounds weightless. In reality, it rests on glass cables, ocean floors, and people who keep the world connected when the sea decides otherwise.